Zoom is doing weird stuff today. I wasn't able to get all around to all the rooms, so sorry I wasn't able to do that. Zoom's kind of messing up on me too. Okay, can somebody share their screen? Somebody thinks they have it.
Yeah, we could.
Yeah, okay, thanks.
So we said the force was going to be equal to the mass times velocity squared divided by the radius, and that the force would also be equal to QVB. So we set those two equally to each other. One of the V's canceled, and we came out with 15 million, etc. meters per second.
Yeah, and I was a little interested in that. That's like 5% the speed of light, so it's going pretty fast. So those arrows you have, that's for the force that's toward the center, right?
Mm-hmm.
So in this case, if people are practicing the right-hand rule and it's a positive charge, a proton, I think the magnetic field's into the page, right?
Mm-hmm.
Yep.
Yeah.
Okay, any questions? So the thing there I wanted you to see, I want everybody to see is we had to use an idea from last year, mv squared over r. So QVB sine theta equals mv squared over r. All right, they give Josh a hand. Yay, awesome, yeah, awesome. Yay. Okay, let's see. Let's go ahead and go into the fourth problem. Wait, actually, before we do that, let me share my screen.
Fine.
Because I'm not sure we need to do all of it. Let's see here. The fourth problem. It's the magnitude and direction of the magnetic field. Okay. Actually, I think we can probably do this one together, part A. It says, what is the magnitude and direction of the magnetic field wire B is in? That means it feels due to A. So what you have to do is ignore B for a second, use your right-hand rule, and you're gonna grab A. So that means your thumb is pointing downward because the current in A is going downward. And your fingers, so now imagine over there where B is, your fingers are kind of coming up through the page. So that means over here where B is, there is a magnetic field that is up through the page. So let's see if I can make that a little smaller. So the question I have for you is, how would you figure out the magnetic field, the magnitude of it? We just use right-hand rule to figure out the directions out of the page. But how would you figure out the magnitude of it?
Ampere's law?
Say it, I didn't hear you. You cut out on me.
Ampere's law?
Yeah, Ampere's law. Yeah, that was the closed integral of B dot dl equals mu naught times I enclosed. And the I enclosed is going to be this I2 over here. Okay, so I'm going to have you, I think I will have you do part A. I want you to figure out what the magnitude is. So let me stop sharing and you go ahead and go into the breakout rooms. Okay, I know I didn't give you a whole lot of time there, but I only want to do one more after this, and I don't want to go too much over 45 minutes. Did anybody have enough time to do this one on their whiteboard?
Kind of got it.
Yeah, okay.
I think we got an answer, but we weren't able to draw the diagram.
Okay, what'd you get for an answer? Oh, Aiden.
Yeah, that's what we did. I don't know if we did the DL right. I don't know if DL is 1 or 2.
Okay, let's see. Okay, so B dot DL equals I enclosed times mu naught, okay. And so you said 10 amperes, that makes sense, times 4 pi epsilon, or 4 pi times 10 to the negative 7th, that's mu naught. The problem is you divide by 2,
Yeah, that'll be.
that really should have been the distance away because, yeah, that really should have been 0.01, 0.01.
Yeah.
And then you get the right answer. So I got an answer of 2 times 10 to the negative 4th.
Yep.
2 times.
Why do we do the total current instead of subtracting them since they're opposing directions?
It's on B from A.
Yeah, you want the force on B from A, so you don't even.
Oh, that
care,
makes sense. Okay.
You don't even care about the current through B. You only care about the current through A because A is the one that's creating the magnetic field that B feels.
So if we were looking at like an independent point, like let's say we wanted the middle between A and B, then we would subtract, or no?
Well, if the question wants to know what is the magnetic field at some point between A and B, then yeah, you're going to have to find the magnetic field from A and the magnetic field from B. And I'm not really sure if you add or subtract, I have to use right-hand rule. Let's see. In between the two, from A, it's up. And from B,
Oh, you have to add.
from B, it's also up. So it's actually adding, yeah. So again, the answer I got was 2 times 10 to the negative 4th. Okay, give Aiden a hand down there. Thank you. Okay, and if you could stop sharing.
Gotcha.
Okay, so there's one more I want you to do. I'd like you to do part B. And actually, maybe I need to share with you. So here is part A. Sorry, let me go to part B. Part B is now we want to know what the force is on wire B. So you just found the magnetic field, and now you want to know the force. So Mark, are you going to have to use the current through B now to find the force on B?
Yes.
Yeah, because you're going to use BILsin, right? BILsin. So you just found the B field, that's part A. Now you're going to find the force. So let me go ahead and stop sharing and put you in the breakout rooms, and this will be the last one we do. And again, this is the last one we're doing, okay? So is the video still cutting out on you guys? It's getting better. Okay, good. Okay, I know I didn't give you a whole lot of time on that one, but I want this to be our last one. Can somebody present this one really quick?
I can.
Oh, perfect. Awesome. Okay, so so you get 5 times the current of, wait, no, that is the current. So was,
All right. I had it in the wrong order.
yeah, I don't, well, actually, I don't think, is that the point, is the 0.00126, is that the B field?
Yes.
Oh, I got a B field from the last one. I got a B field of 2 times 10 to the negative 4th.
Mm.
Because I
Okay.
did u naught times 10 divided by the quantity 2 pi times 0.01. 2 times 0.01.
Okay. I did that last wrong
So,
again.
yeah, so that I think everything else looks good there except the 0.00126. I think it should be 2 times 10 to the negative 4th. But everything else looks pretty good there. And you end up getting the answer of 0.002.
Okay.
And the most important thing I want to talk about though there, so don't go off your page. I want to look at it still. He has to the right. Could you tell us, Matt, Matt, can you tell us really quickly how you figured out that force was to the right?
Since the flow in wire B is going up, your thumb goes up, and then the magnetic field is going towards you. So
Okay.
then your palm is facing to the right.
Okay. So before we leave this, I want everybody to look at this. So if there's a force on B to the right, which direction would the force on A be? Everybody.
Left.
To the left, that's Newton's third law, action, reaction. So if we found the force on B to be 0.002 to the right, the force on A is going to be 0.002 to the left. So these two things are repelling one another. So I want you to look at the picture. When the current is going in the opposite direction of these two wires, they repel. What do you think would happen if you had the wires that were in the same direction? The current was in the same direction.
They contract.
Correct.
They attract. Okay, give Matt a hand. Yay. Awesome. And then if you could stop sharing. Okay, so let me share my screen real quick so I can go back to the calendar. All right, so we'll pick up there then later. Let's see. Oh, I need to talk, shoot, I need to talk about this lab. Okay, for this lab, you'll want to click on this link here. And there's directions. I'll let you follow those directions. And what you're doing is you're going to be kind of taking up some observation. It's totally conceptual lab. I don't think it'll take that long. There's a video that I'd like you to watch first that I made that I just want you to see how, let me go back to this picture. I want you to see how this green thing works. It's called a galvanometer, and I want you to see how it works. So I would like you to kind of watch that video first. All right, and then finally the attendance quiz. Okay, the code, oh, by the way, this attendance quiz is just over this worksheet we just whiteboarded, okay? The code is 345-923-084. 345-923-084. And before you leave, I want to get a picture, you know, like I usually do, except I want to do it different. What I'd like you to do is if you have a pet, maybe go find your pet. It could be, you know, a hamster, goldfish, cat, dog, whatever. And I want you to hold it up in front of the picture, in front of your screen so I can take a picture. Like, if you don't have a pet, maybe a stuffed animal. I don't know. Your favorite cuddly thing? I don't know. Okay. I'm at school, so I can't grab one. Sorry. Had some great pictures today. Dogs are very photogenic.
I can't catch my dog.
What?
I can't catch him. He runs away.
What?
Mr. Linfesty,
Yeah,
I have kind of a weird question.
sure.
Is
Oh,
my piano still in the physics office?
It is. It's back here.
Okay, I was just
I-
wondering.
I think sometime at the end of the school year, they're going to have you guys come back in and like bring books and stuff back in. So
Oh.
we might just have to email so that you can come in and get your piano too.
Okay, that sounds great. Thank
I
you.
can't wait to see you guys again.
Well, I don't know if they're all going to have us in the building at the same time. It
Oh,
might be just
shoot.
scheduled times, kind of a shifting. Spencer's dog. That's awesome. Okay, is everybody back? Is Ben back? Yeah, everybody. All right, so, okay, count of three, kind of hold your pet up near the, if you have a pet. Okay, ready? 1, 2, 3. Okay. Awesome, that's great. Okay, let me save that. File save. Okay, so, okay. That was awesome. Thanks for letting me do that. And then today's Wednesday, so I guess I'll see you on Monday then. All right, so that's it. Thank you very much. Appreciate your time. Thank you. Bye.
Yeah.
Thank you.
Bye.
See you, Michaela.
We had a dog, Adam's dog. That's awesome. What kind of dog is that? Miranda, what kind of, oh. See ya, bye.